Purpose here is really about providing tips for future VDI deployments, but also looking at some of the new technologies that are out there, not just the storage side, but also the UEM side, the mobile side. I won't touch into the mobile too much because it's still going to be a storage slanted presentation, really, because that's where our expertise comes from, but definitely not a sales pitch. So this is our agenda. We're going to go over what does end user compute really mean. So we use EUC. It's kind of been a new term over the last few years. A lot of people interpret it just as VDI. So most of this session is really going to be about VDI because that's where storage kind of plays the most impact. But it's also going to be about why is it so difficult around scaling, and this is the size aspect. So obviously a lot of people have done POCs where they start with 50 desktops, 100 desktops. How am I going to deploy this out to 1,000 or 10,000? Or in some cases we've done 70,000. Obviously the rules are different. So I am EUC Architect. There's my Twitter handle. So I spent my beginnings of EUC, I actually worked for VMware for about 8 years. Worked in all different departments. I started out in the field, did pre-sales, post-sales. I worked in product management for a little while. Loved working at VMware, but I was given a really good opportunity and came over to Tintri to really build out our EUC business. So that's where I am now. So what is end user compute? So there's a lot of terms that you'll see out there. EUC, of course, is end user compute. UEM, you'll hear that a lot from companies like Liquidware, AppSense. Now, of course, VMware has all the things with app volume. So UEM is user environment management. Won't talk about it too much, but it's one that's becoming a lot more prevalent. VDI, I think most people know, virtual desktops, virtual desktop infrastructure, or as some still call it, virtual desktop interface. I think that's a really old one. And then some others that come from what Hyper-V is doing around virtual desktops. Obviously, we're not going to talk about Hyper-V at all. But it is out there, and there are a lot of customers using it. Obviously, we still feel there's a lot more advantages with the VMware platform and the Horizon toolkit. At the end of the day, what it really comes down to is delivering applications to the users. So there's an old phrase that we used to use. It's all about the apps and the data. Because really what it is, when you say end user compute, you're looking at where the user is, what are they trying to get to? They're trying to get to both applications and they're trying to get to their data from every device. So in the early days, we said, why not to do VDI? Because there were a lot of customers coming to us asking us, why are we going to do VDI? And we said, okay, why don't we turn this around and say, why not VDI? And really, in the beginning, a lot of it was around the high cost of storage. We did a lot of cost analysis, and when you looked at what the cost like per desktop was, storage, and when this report was done, this was probably about 2 or 3 years ago. But if you go back even a little bit farther, like in the early days, like View 3.0, when it first came out, if you did a virtual desktop analysis of what you were trying to deploy, I think storage would come out to about 50 to 60% of the total cost. That even included software. That even included Microsoft licensing because the storage was just so expensive and it wasn't really built specifically for VDI. And so that's the beauty of kind of where we are now is there's so many more solutions that are built specifically to handle VDI workloads. And so it's brought that cost down a lot, even much lower than that 41% you see now. So when we talk about what storage platforms can bring us, so conventional storage, a lot of the issues you hear terms like boot storms, we've done a lot of these issues. Antivirus was a big problem. In the early days, a lot of folks would take a physical desktop and they'd literally do a P2V, or they would build a desktop image that was based directly on what their physical desktop looked like. We even still see some of that today. And then you take that and you take all these problems that existed with the physical desktop and then you multiply it by 1,000 or you multiply it by 5,000 desktops. And so none of that's going to work, especially the antivirus side. Now we have extra tools where we can take that antivirus out of the desktop. We can put it in the hypervisor layer to be able to, really take that workload off of the storage. And then it was really about folks would look at what the storage needs were for the desktop and say, well, we'll just buy more disk. We'll just throw more IOPS at it. We'll throw more capacity at it, and that'll take care of the problem, not realizing what the cost of that really is. So we have performance isolation. This is really a key point for a lot of the new storage platforms that are out there, the VDI specific workloads, where you can look at individual VMs. And I think a term that VMware used for years on the server side actually kind of lends itself this way is the monster VM, or we call it like the noisy neighbor, where you have maybe there's an application out there that only a handful of users use, and for whatever reason, it's impacting performance on the rest of the desktops that are out there. So there's that side of it. There's full visibility toolkits now, so you can go into the storage, you can see things like what are my IOPS on a per desktop, what are my IOPS for a group of desktops, what are my IOPS on a whole data store. and being able to see it not only in real time, but historical data as well. So all the new platforms you see out there, they're giving all this. And even when you look at like a Pernix data, where they're not selling the hardware themselves, they're just adding extra visibility into what your storage is doing. And it's really key for these VDI workloads, because once a problem starts to occur on one desktop, it's probably going to replicate itself by however many thousands or hundreds of desktops you have. So other enhancements, really simplicity is kind of a big case. When we started doing a lot of, building out, you do a POC, you do 100 desktops, you're like, I've got a data store, now I want to blow this out to 2,000, 3,000 desktops. Now you've got multiple data stores to manage. In some cases, it was dozens, even as many as 40 or 50 data stores for a given environment. And that's in one vCenter, and it becomes kind of a nightmare to manage because each one may perform differently. So now with a lot of the new platforms, it's I can present a single data store, I can throw everything on, and it doesn't affect performance because I have visibility into everything within that data store, and I have enough IOPS because I have things like flash disk and I have hybrid disk to be able to give both capacity and performance. Improved deployment speeds is really a big one. The VDI plugin to be able to, where the storage appliances are now talking directly to the hypervisor, they're being able to offload some of that work, and they're really solving a lot of the bottlenecks that we've had for so long. And all this stuff is just new in the last couple of years. So PowerShell toolkits are a big one. Open APIs are a big one. This is something that VMware has always really touted upon, is having APIs in all their products so you can do whatever customizations you want to do. So it's purpose-built storage, and this is kind of what I've been talking about around the storage side, is visual latency. So a lot of the tools out there now where you can look at individual storage latency per VM or per groups of VMs, but you get to see all the latency. So it used to be you could go into ESX, you could run a couple of the tools, you could see the latency in numbers. Well, now we see it in graphs, and now we see it in both real-time and historical. And then you can do your QoS based on that. And again, this is the noisy neighbor situation. So again, monster VM style. But really it's about all the metrics that you can handle, but it's in a usable state. Whereas before it was like, hey, we can output this to a report. It's going to be 100 pages long, or you're going to get data, from every VM. But now it's the visual analytics side of it. And there's so many tools out there that really do a good job of having usable UIs where an administrator can go in and quickly see where the problems are. So this is one of the few slides where you actually see a Tintri product on there. This isn't specifically for the Tintri product. This is really just to talk about the different types of storage appliances that are out there. In most cases, what you're going to see is you're going to see an all-flash, or you're going to see a hybrid based. Now, all-flash can be any size. I mean, obviously, you look at like SolidFire has nice big devices. We have a smaller appliance. It's just a 2U appliance, but it scales. And then we have our hybrid appliance. And it's really, you have to understand your workload, understand the requirements of what your VDI users are going to need to figure out which one makes sense. In most cases, a hybrid storage model makes sense. A lot of times, customers are going to be very cost conscious. They're going to look at what is my cost. Some analyze it by per gigabyte. We try and stay away from that because usable gigabytes can be a really complex conversation. It's more about how many desktops can I run on this one device, and so then it's a per desktop cost. Obviously, all flash is going to go, give you, the more IOPS, but a lot of times, even if you're running thousands of desktops, you may not need that many IOPS because a mix of flash and spinning disk is really going to solve your problem. So, off of the storage for a little bit. Why is running VDI so difficult? And this really lends itself to years and years of experience from VMware, from working with you guys in the field, from other guys like you heard about Josh Spencer before. He and I actually worked together at VMware years ago. He works at Pernix now. But we did a lot of this stuff, whether it was small POCs of 50 desktops or big government deployments of 70,000 desktops. So it was expensive, and this is one of the key items early on. It was your per desktop cost was significantly more than buying a physical desktop, and so the only industries that were really pushing us for it was like healthcare, financial, some government-based stuff. Occasionally there was some education mixed in there, but really it was about unpredictable workloads because the platforms that were being built were for server virtualization, not meant for VDI. And so there was no QoS specific to running thousands of desktops. It was QoS to hundreds of server workloads, and server workloads are very different, especially on the storage side. We say it varies on IOPS. We have a number up here, 10 to 50 IOPS is pretty normal for most of your desktop needs. We've seen applications where an individual application by itself needs 100 IOPS per user. We've seen others where a full user desktop with 30 or 40 applications on it, they never pass 5 IOPS. So it really comes down to understanding what your users are doing, because when you look at individual workloads, one user going from 5 IOPS to 100 IOPS is not that much. Multiply it by 1,000, 5,000, that's when it becomes a problem. And it's those heterogeneous workloads where a lot of people were taking the virtual desktops and putting them into a server virtualization environment and then trying to grow it from there. That was another problem. You say, okay, we want to stand up a POC. Here's 50 desktops. Hey, it works great. This is our existing vCenter, our existing host, our existing storage that we use for our server virtualization. Well, now let's just add 500 more. We've got capacity. It'll work no problem. And not really scoping it out as an individual deployment. High latency is another one. Now, latency comes in a couple different fashions. Obviously, on the storage side, we can talk about that all day. But there's also the network latency. And this is where, especially when you're doing hosted desktops, where it can become an issue. And it's really about understanding your application. So if you have a user that lives in LA and is logging into a data center in New York, I mean, your latency minimum is still going to be 75 milliseconds. And if they have a latency sensitive application, it's becoming an issue. And one of the companies I worked with early on, they had a data center in San Jose, they had a data center in Dallas, and then they tell us that most of their users are in the US, but they have a bunch of users that are overseas, even in the Philippines and Singapore. And we said, well, round trip, your latency is going to kill the performance. And when we analyzed it, we could get it down to about 250 milliseconds. But at the end of the day, it wasn't really a usable experience because the application was too spotty because of that. And so they ended up having to, host desktops out on, that side of the world. And it was the only way to satisfy it. So again, it's understanding what the application itself needs, understanding how it affects the user environment and the user experience. So really what we want to get to is how to help your end users, what to build out, how to build it out. So this is when we use a Tintri quite a bit because it's really about, especially with a lot of Tintri customers, we have existing virtualization customers. Most of Tintri workloads are, I think, 85, 90% are VMware based. And so we say, okay, imagine that the pot of chili is your existing virtualization. And what you want to start with is a POC. I want to load up a couple of desktops. I'm going to test out some different applications. I want to get some pilot users in there. I want to do some QA. And everything looks good. And everything runs great. And they've got tons of storage and tons of IOPS and tons of capacity, tons of CPU, RAM, everything. Then you add a little bit more, no problem. You go from a dozen desktops to maybe 100 desktops, still looks good. But eventually you get to a point where it's not going to run the same anymore. Now you need to scope it as its own environment. Because once you start talking about, well, I've got, 700-800 users. Well, if your server virtualization is relatively full at that point, adding 100 desktops may not overload you, but adding 700 is going to. And you need something that's more purpose-built. You need something that's specifically for VDI. And what it really comes down to is understanding what that overflow is going to look like, what that extra capacity is going to look like. And again, it will always come down to where are the apps and the data. The data is going to give you capacity. The apps are going to tell you what performance you need. And so running a VDI like you would normally run physical desktops is where it becomes an issue because most companies have been built on some kind of desktop support, some kind of desktop architecture that they said, this is how we've delivered apps forever, this is how we deliver desktops. Well, when you start going to VDI, it's going to be much different. Antivirus is probably the first place to start because you can offload that work and instantly your environment's going to run better. This is actually where we saw a lot of VDI workloads in the early days really fall over, is they said, okay, these are the apps that we get, we send everything out, whether it's through some app management tool, and they load up and antivirus is there. And next thing you know, they're running 1,000 full desktop scans on a Saturday or Sunday, and they wonder why they're getting calls and why everything's falling over and none of the machines are available Monday morning. Now we have the tools. So it's built in where you can actually run any kind of antivirus directly on the hypervisor where it scans the individual desktops themselves. The other side is there's a lot of different ways to deliver the desktops. Full desktops is the easiest management style because it's just building individual desktops and then multiplying it by 1,000. But with all the new tools out there and a lot of stuff that Sean was talking about in the first session around that user environment management, the app stacks, everything else, now we can go to what we call non-persistent desktops where the desktop itself doesn't actually need to exist for more than a few days, in some cases only a few hours. We have customers that are doing refresh rates at every 8 hours. So for one shift, a user has that desktop and it gets refreshed, and when they come back in, everything gets delivered on demand, and it fits into that just-in-time desktop model. where users coming in, they're getting presented their apps and their data independent from the workstation itself or independent from the virtual desktop. So makes patch management, GPOs, makes all that much easier, but the architecture takes a lot longer to build, and you got to set up all these additional tools. That's why we say full desktops, persistent desktops are easier, but they're not necessarily the right solution for every user. So when we talk about performance, especially with storage, a lot of people will focus on IOPS. And so they'll analyze one desktop and they'll say, hey, this guy needs 400 IOPS. They'll analyze this other desktop, he needs 100 IOPS. So what are the real resources behind that? Well, the problem is IOPS isn't the only question that we have to ask. The other side of it is what's block size? So if you have a smaller block size, a lot of times you're going to have more IOPS. And so in this instance, you have 400 IOPS versus 100 IOPS, but the 100 IOPS actually has more throughput. And this is where we ran into a lot of situations where customers were looking at just IOPS and not evaluating every other aspect of what that desktop does. Now, don't get me wrong, IOPS in most cases is probably the single most important aspect of storage performance for virtual desktops, but it's not the only one. So the other problem we run into is all the different users that are out there, and everybody needs different performance. Everybody needs a different level of IOPS, different level of CPU. Now you have 3D coming into the mix, and you have grid users, and you have applications that are more intensive. A really good example was we use a lot of assumptions when we're building desktops, and we had a use case where a user called us and said, hey, we're having really trouble performance with these VDI machines. Once we go past about 25, 30 machines, it really slows them down. And we were trying to understand the use case. And so they explained it to us. They say, well, they're loan processors. I said, well, what kind of applications do they use? They say most of the time they're just working in PDF. They're just viewing PDFs. It's not really that intensive. There's no 3D video or anything crazy like that. So we said, okay, we'll go out there, we'll take a look. And so I sat down with the loan processor and I asked them, I said, okay, what are you doing? So they log into the machine and they've got these two huge monitors. And they open up a PDF in this window and they open up a PDF in this window. And they're literally comparing the two of them. And they have two mice. And they're scrolling through both of these, absolutely stocked full of pictures. And most of them were pictures of homes, pictures of cars, but the speed at which they were going through them, it was trying to load every single image immediately. And what we found out is the bandwidth requirement for that one user was equivalent to a 3D video because of the way they were using the application. But you'd never understand that unless you sit behind them to really understand what the use case is. I mean, when you hear, oh, it's just a PDF viewer, they're just looking at loan documents, oh, it's mostly text, no big deal. But when you really understand what they're doing, that's when you're going to learn, and that's when you can scope it properly, because now we understand, okay, bandwidth requirements of these guys is significantly higher than your average user, especially when we had loan officers that were overseas, and they were literally just working with text, and I think their requirements are like 50K versus like 7-8 meg. So. And it's really just understanding, and every single VDI solution, whether it's Hyper-V, whether it's, even Citrix, which I don't like to talk about too much, but all the different products within VMware, it changes the scope of what you're trying to do. So really what it comes down to is we want to assess. And so some of the companies that are out there, Liquidware is I'm a huge fan of. I know all the founders, a lot of them, started at VMware once upon a time. They have a great tool called Stratosphere, allows you to load it up into the desktop so you can really assess, but it gives you that application level metrics where you understand what the application itself is doing. And that's really the key to scoping any VDI, any EUC is the application itself. You have to understand how that thing performs, but also how the users are accessing it. 7-8 years ago, it was just how users were getting to the apps from a desktop. Today, it's how the users are getting to the app from a desktop, from a mobile device, from an iPad, from a phone, and they want to have full access. And everybody wants a native app now, and they want it all to just work. And they don't care about security, and they just want to make sure their stuff is secure. So you assess, you use these tools, you'll understand what your users are trying to do, it'll help you. The other side of it is a lot of these assess tools will also spit out, you say, I want this server that I'm going to buy and this storage that I'm going to buy, and it'll spit out and say you need to buy this many servers and this much storage, and it'll give you at least some guidance on what the architecture is going to look like. So a couple of tips. How are we on time? Oh, I'm good. Going faster than I thought. So this is where we talk about the human element. This again is kind of the understanding the users. Sometimes it's sitting with them. Another example that I like to use is This is back in my old help desk days. I got a phone call one time, and a lady tells me, she says she can't log in. She says, oh, I've changed my password. We're trying to change her password for her, but nobody's sitting with her. And we didn't really have the remote tools to be able to understand exactly what she was doing. And so I had to go down and find out what was going on and why she couldn't log in. And what we found out is the user field, she had switched desks, and so the user field was being pre-populated by somebody else's account. She would literally highlight it, hit the space bar, and then type in her username. Well, her username doesn't start with space bar, but she wasn't hitting delete. She was hitting the space bar. But nobody would know this unless you're sitting with the user, understanding what they're doing. And so when we talk about the human element, this is what we're talking about, is understanding how the users use the application. I mean, again, in the previous one, you hear PDF. We all know how to use a PDF viewer. We know what it looks like. But this person was using it so much differently than anybody else had ever used it. And until you understand what that use case looks like from the user sitting at their desk, from doing their work day in and day out, that's going to be the key, and that's how you can really get a VDI, get a end user compute solution that's going to satisfy all their issues. So, building an image, this is really critical. Can't stress this enough, and this comes after the assess phase where you understand what your users are going to look like, especially if you're building out full clones. You want to know every application that's going into that, what your optimization looks like. There's all kinds of tools out there today to optimize that image, to pull out stuff that doesn't need to be there, that's going to affect performance. Talk about things like pulling out print drivers if you don't need them, pulling out the antivirus if you don't need it, and putting it at the hypervisor layer. When you build that image and then you go in, if you're doing full desktops especially, and you deploy it out to 5,000, every single little thing that you miss will be multiplied. Even if it's a little bit of CPU here, a little bit of IOPS there, it adds up really quickly. And with all the tools that are available, and I'll show some of them, I don't know if you guys know about VMware Flings, but they have a couple that are out there that really can help you guys kind of hone this thing out. So we like to say enlightenment because it's virtual desktops, and once you understand how they're getting deployed and how to build them appropriately, you feel somewhat enlightened. A lot of us have all the battle scars for years and years of doing this, and unhappy end users. And that was the most common, is you build out a solution, you can show through metrics that it's performed better than the original desktops did, but yet you'll still hear from the end user that says, well, it doesn't feel like it's as fast. Like they expected that if you're going to give them a virtual desktop, it's going to be twice as fast as what their previous machine is. And we could even show at times, I can show you a metric where Microsoft Word launches in half the time it used to from when you're logging in to when you're actually productive. And even that, they say, well, no, it just feels slower. And so getting the end users to really buy into what you're trying to do, and doing things like getting them to test those devices early on, getting them to test the software early on, and getting them to be a part of the process, I think that's really where you can be successful. And this is where most of our projects were more successful, when we got the users involved. And so, being able to show them how you're building it, and looking at things like the client-side connections and being able to test out each device individually. And then, do we really need all the printer drivers that you have? Do you really need to be connected to all this? But then also being able to take all that stuff out of whatever desktop image you're building is going to be, a huge advantage. So testing, again, we first talked about assessing, we talked about building your guest image, but testing is really where it comes in as well, because you can't really recreate anything exactly like your production is going to look like, but Login BSI does a pretty good job of testing it out on your new architecture. So say you're building out you get new servers, you get new storage, you build out your image, and you want to test and you want to see what production workload is going to look like. Login BSI is a great tool to be able to just go in there, and it's all GUI based. It's nothing programming that you need to learn. I mean, obviously they have PowerShell scripts that you can build, and you can get custom with it if you want to. But really, it's just you go, okay, I got a handful of applications. You can select from hundreds of applications that they have built in, and they'll run automated workloads. And it's not just standard, hey, it's going to launch Word, it's going to type a few letters. It really does do a lot of randomization built in there. So Login BSI, we live by it. We do with a lot of customers where we'll load up a whole environment. We'll show them hundreds, even thousands of desktops from a single Login BSI workload builder. So it will always show you anywhere you're going to have problems, and it's better to see those problems before you start putting actual users on that workload. Visibility analytics, we talk about this a lot. Being able to go in and being able to say, hey, I can see where a problem's coming in. I was actually talking to somebody earlier where they said, you start putting users on and you can actually go in and you can see in real time where the latency is, where the workload is, not just in the tools like the Tintri has, the other storage platforms, but also from vCenter or from the VROPS toolkit to be able to go in and say, okay, the user's going in, they're launching an application. Hey, now I can see the latency that they're building in. And it's actually pretty eye-opening when you watch it in real time because you can see them switch from different apps and which apps will actually hit the storage harder, which apps will hit the network harder, which apps will hit the CPU harder. And that's another way to try and understand what the applications are doing because you can see a lot of that stuff in real time. So technically, this is a screenshot from Tintri's UI, but a lot of the VROP stuff will look relatively similar depending on what graphs you're trying to use. And so CPU, memory, disk. We talk about disk latency quite a bit because we think that it has probably the most significant number when it comes to desktop performance from the storage side. So I talked about VMware Flings. There's the URL there. Again, none of these are fully supported. If they ever get fully supported, they come out of Flings and they become an actual product, but all these are out there. So I just put a few of the ones out there that I like to use the most. Again, the OS optimization tool, the one down on the left, that's one of the key items, I think, because, again, guest customization, optimizing what's actually in the OS and being able to pull out stuff that really is unnecessary. I think one of the early offenders was like Arrow was a big issue, drove CPU and IOPS absolutely through the roof. Horizon Toolkit or Toolbox 2, this really just gives you some more administration tools to make things a little bit easier. Some stuff that were manual tasks, you can automate some of it. The ThinApp vSphere client, that's really just a nice one to have because it's literally an executable that you can run around to anywhere and you can load it up and you can log into your vCenter. So, and then View Pool Manager, and this is really about creating multiple pools. So again, there's all kinds of scalability issues to different versions, but being able to have something that can create multiple pools for you, have consistent naming conventions, this is always a nice one. I don't know if anybody's ever done this, but if you go into a lot of Horizon environments, you go into the View Manager and you see all the different pools and everything's a different naming convention, you can't figure out what anything is. So being able to manage some of that stuff is definitely a big help. So other tips and tricks, VMUG community, all you guys, I mean, obviously everybody's online. I have learned more from you guys over the last 7-8 years than from anywhere else. I hear from guys like Sean Bass, I hear from other guys that'll speak, but it's really from the stuff that you guys are doing as actual customers. Things like looking at the BIOS, CPU power savings. Some of this stuff is important because sometimes you'll build out a View environment, you'll build out thousands of desktops, and some things will come and bite you where, okay, during the day we have, 1,200 people logged in, and then at night we have, 300 people, and some of the hosts will get quiet, and then they'll go into like CPU power save mode, and then 500 users will try and log in all at the same time, and they won't understand why they can't. And that's one of those issues, and it's just one of those things you don't really think about until you go in and look for it. So. Templates on the same data store, this is a key one. Obviously, this goes into a lot of architecture decisions, but it's really about making sure that especially when you're doing non-persistent, they got the clones that are out there that exist, but it's really about deployment time. So if you have a given template, if it's a big template, especially when you start doing full desktops, even if they're thin provisioned, it still can take a little bit of time. It can add latency if you don't have it on the same data store. Streamline your image. Again, this is around the guest customization we talked about. Running the antivirus in the hypervisor, can't say that one enough just because it takes a lot of the workload out, especially with full desktops. If you're doing non-persistent, there are other ways to get around not having to do full virus scans, and maybe you can leave it into the VMs and not have a huge workload. But a lot of times you're not going to want to go past 7 or 8 days on something like that. So you got to make sure that the machines are refreshed often enough to be able to take care of that. Again, purpose-built tools. Liquidware is not the only game in town. I just prefer Liquidware, but I have worked with Lakeside a lot. They're really good. There are others out there. It's obviously a growing space. Everything EUC is a growing space. That's why you see a lot of these new vendors. But definitely have an assessment tool. It cannot pay for itself fast enough. And then again, like I talked about, getting customer buy-in, getting the users themselves to come in and be a part of the process. And you'll learn more having your power users come in and say, okay, I want to test it out, and not just for 10 minutes. Like, you want them to give them, a pilot machine and let them work on it for, a day, a week, and give you real feedback to understand where the nuances are for that user. And the more you can understand that, the more they're going to believe that you're actually trying to help them. And the more it's going to be less of the, well, it feels slower, and more of the, them telling everybody else that they need to get a virtual desktop. So that's it for me. Again, I can answer any questions, Tintri, that anybody wants to. I love the product, obviously. That's why I went to go work for the company. But I was really here just to talk about VDI kind of as a base model, and to kind of help you guys, especially for those that are just getting started. So thanks for the time.